Good afternoon, gentlemen. Hope you all are doing well today. It is the 21st of April, and I'm in preparation for the Thursday lecture. Wednesday has already been complete by Professor Vermelin and will be posted for Wednesday, and I'm going to be working on the Thursday one here for you in video. And we've done some switching around, so hopefully my audio is a little bit better. And Professor V, are you there?
I'm here.
I hope Professor V is sounding much better to you guys also. So, Professor V, what was your one for Wednesday? What was your subject?
Reclosures, single phase, hydraulic, and electronic.
Okay. So we're going through the system protection devices, and that's what we've been working through. Of course, the top level was the breaker, and you got your questions for that one. You saw how it operates, and I have to tell you guys, in speaking with Professor V, I know we probably went a little in depth there, but there's a lot of safety features you need to be aware of out there that are working for you, that are good questions to ask if you don't know them within your utility, especially if you go to work on a feeder circuit or a tap line out there and it's on overhead, and you come up to the crew and say, well, do you have a hotline work permit, or do you have a one shot on that circuit? And if they say no, you know what you need to do. You need to ask for that to happen. So I hope you're grasping this well. I think it's carrying on well. We haven't had very many questions. Of course, we're available if you do. So Professor Vermelin went through the reclosure part of it, and simply put, a recloser, and Professor V, correct me if I'm wrong here, there's a recloser in a breaker in a substation.
Correct.
Reclosing relay, and it does reclosing on its own. And a line recloser out there, I haven't watched your stuff, Professor V, yet, so pardon me if I'm double dipping here. It is really moving the reclosure part out of the breaker into the field.
Correct.
Yeah, and the purpose for that is to just isolate long feeder sections. So if you got a real extensive long feeder out there and you want to sectionalize that long feeder, I mean, typically you're going to put a reclosure about halfway on that full feeder circuit, so you have reclosing capabilities further out on your system, and instead of having 100% of your customers off on a long feeder, you only have 50% off because the recloser recognized the fault beyond itself. Now, of course, if the fault happened prior or before it got to the recloser where it's located at, then you're going to lose the breaker. So
Right.
those things. And there is a little bit more technology in a breaker as far as it operates, a timed operation. A recloser is just kind of dumb. It just counts.
Right.
Yeah, it doesn't do like the instantaneous and timed wait and all that kind of stuff. It just counts how many faults it's got on it, and then whatever you program it for, it's going to reclose for that amount of times until finally it stays open. Okay, so to move on, with system protection continued, and you see it here in my Word document, Professor V, can you see my screen?
I can.
Okay, great. Sectionalizers, we're going to go into that. That's the next step. So breaker, reclosers, and sectionalizers. Sectionalizers come in various varieties. There's a single phase and a three phase. Single phase, of course, just monitors the one phase, and a three phase one monitors all three phases. So what's its purpose? Well, its purpose is to do exactly what the word is, sectionalize. Excuse me for a moment. Sectionalize or isolate a line section due to a fault. Well, the recloser does the same thing, except this just does it without reclosing. Three-phase opens all three phases at the same time regardless of fault phase. So if I have a three-phase, I'll get you a picture of it right here. I got all these pictures all lined up. A three-phase sectionalizer, and this is something you probably need to do, and I'm sure it's going to be in the video, and Professor V talked about it. It is really hard to disseminate or tell the difference between a reclosure and a sectionalizer. They almost all look the same. And the easy way to find out is all of them, and you see this little pipe coming off the side here, have some kind of control down at the bottom. And in that control box, if you just open it up, it's going to say recloser, or it's going to say sectionalizer. But they almost all look the same. So if I have a fault on one phase, all three are going to trip open. That's what this is meant for. It could happen on any one of the one phases here, or it can happen on two, or it can happen on all three. But if just a single one, say I have a fault, a tree limb falls in this phase only, then the whole thing is going to open up and sectionalize that line section. Okay, so single phase, three phase opens all three phases. Single phase only opens that one phase if fault is detected. And I already showed you the pole mount three-phase picture. The single phase switch type barrel picture, I'll show you that one next. I kind of wrote myself a script. So, nope. Well, why is it moving around? Nope. Nope. Ta-da! All right, here we go. Now, this is a cutout switch. No arrestor on it yet, and of course no wire in it. We really don't need that for this purpose. This is what they call a sectionalizer, a single-phase sectionalizer. Now, from the picture, I cannot tell, but they do have two types. Do they have a three-count sectionalizer, Robbie?
Yes.
Okay, so they have three different types. When I say count, it does counting. It does fault detection, and it actually counts inside this module right here. So there's an amp meter in here detecting fault current, and digital circuitry in here that's actually counting. And I'll let you know what they're counting in just a moment. So I can have my jumper coming into the top of the switch from a feeder, and this going out to whatever I wanted to tap. These are not used on transformers. These are used on tap lines going into high load areas. Now, when I say high load areas, a regular fuse in a switch of when you see that nature, and I'll show you the switch here in just a moment. The highest size fuse that you can put inside this fuse barrel, which is standard for all switches, it might be different on this side, but any new switch that comes out is standard, is a 125. The braid on the rope is so big on a 125, you get anything bigger than that, it won't fit through the barrel. So, what was their solution? I still needed some kind of protection. They go to these sectionalizers. All right, the sectionalizer, every one that I've seen, they might go a little bit higher. We'll do up to 300 amps. So this is going to be feeding a high load, high amperage area. A good example, we've got feeder along Highway 17 in Surfside. Then we have actually feeder line feeding into Ocean Lakes Campground. You know how big that place is and how busy it gets. But we want to be able to sectionalize it or isolate it in case of faults. This is what they use. A 125 is not big enough amp-wise to carry all the load in there. This will go to 300, and it is. So that gives you a good explanation of kind of like the territory or the geographic location of where you're going to put these things at. Okay, so how do they work? The pole mount three-phase detects a fault downstream and waits for breaker operation. Well, what do you mean wait? When the sectionalizer loses voltage, it counts and opens on a pre-programmed count. So, what do I mean by this right here? Well, it's waiting for the instantaneous operation. Remember, the instantaneous is an open and close very fast of the breaker at the substation. Now, if I can learn how to type, what the sectionalizer does in this case, let me get back to your picture right here, or these cases, is, here we go. These can be either direction. I can come inside and go out, or I can go out and come in. So we'll say this part comes off the feeder line. This is what's connected to the feeder. And this is what's going into, say, another campground or a large area right here. If the fault happens at this location, it's going to go through the sectionalizer. The fault current is going to go out onto the feeder, and the breaker is going to do an instantaneous operation. Open, close, real fast. This counts it. It counts actually the loss of voltage. When that breaker opened for just that moment, mechanism and circuitry down here counted the loss of voltage. Okay, so it detected the fault. I see a fault current going through here, and I detected one loss of voltage. So I can program this piece of equipment to actually, 1, 2, 3, 4, 5, as many as you want to before I finally open. You'll notice that I've not said reclose. Okay, it's letting the breaker do its work and eventually, whatever I programmed it to, I'm going to open. So it does not reclose, it sectionalizes. All right, a little bit of explanation here. Don't worry about too much about this three-phase one because the single-phase one does the same, and you'll be quizzed on this part right here about the steps. The switch barrel type, which I had in this photograph. Oh, nope, 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 nope. It's going to be the first one. Yep. All right, the switch barrel type is doing this in single phase, where the other one did it in three phase. It's just easier to explain in a single phase condition how these things actually work out there in the world. Okay, so here we go. And we're just going to give a scenario here. Steps for barrel type, and it's a 2-count sectionalizer, so it's going to count twice. The sectionalizer recognizes a fault downstream. So in my picture right here, this sees that downstream fault current is running through it. This black piece right here. All right. It's got a little ammeter in there that's measuring it. The breaker has an instantaneous operation. So in the instantaneous operation, when it opened, I know it's fast, when it opened, this thing actually did not have any power going to it, so it lost voltage. The sectionalizer counts the loss of voltage. The breaker has an instantaneous operation. Sectionalizer counts 1. Let me put this over here because I'm going to post these notes too. Loss of voltage. Okay. Instantaneous, as we remember, means it opened and closed fast. So it counted this 1, but immediately thereafter it closed fast. So I've got power restored, but the fault remains. So the fault didn't clear. The fault didn't clear down here. So it still remains on the circuit. Sectionalizer recognizes the fault again. Same thing it, whoops. No. Same thing it did up here. Sectionalizer recognizes the fault downstream. Breaker has a now, because this is our breaker scheme, as we talked about before, has a timed operation. So it opens and it does what? Waits to close. I'm in timed wait. The sectionalizer on its own, it now counts, well, I've lost voltage again. Now mine counts now to 2. On the sectionalizer itself, there's a capacitance actuator. So it's actually storing energy, and it fires a plunger. Boom, right out of the bottom right here, that kicks the foot down. The barrel falls open. So there's some benefits going on here when I have an actuator type. Remember, I've lost voltage, but I still have some energy here to kick this down, kick the foot down, open the barrel up while there is no voltage on it. So that means there's no fault current and there's no load when it does open. So no fire is going to be flying everywhere. That's a nice benefit of it. Okay? Sectionalizer counts 2, the actuator fires, opening the barrel, and the fault is isolated. Remember, it was downstream. Well, the breaker closes back from that timed operation. It waited, it might be 1, 2, or 3 seconds. Who knows? Whatever it's programmed for. But doesn't see the fault anymore. That's because the 2-count sectionalizer isolated it. Those are the steps. Plain and simple right there of how a 2-count sectionalizer works. Now, if you need to go into a 3-count or higher, it's just adding on the steps. Timed operation, sectionalizer counts 2, instead of actuator, fault remains. Okay, sectionalizer recognizes it, breaker operates again in a timed operation. Then the actuator fires, so you just need to add steps in between. I'm just going to be asking on the quiz, what are the steps for a 2-count sectionalizer to actuate or fire open? Okay. All right, fuses. Now we're down to the last part. Finally. And I know it's kind of been, this has been a little bit weird to explain online, hasn't it, Robbie?
Yeah.
Yeah. Fuses. Well, what do they do actually? They melt under overload, and we'll talk about overload and fault again, and blow under fault conditions. Now, overload we know, and we've talked about in math class extensively. If I've got a 10 amp fuse, it will do 150%. So it'll actually do 15 amps for a short-term period. Well, what's going to happen if I go to 16, 17, 18, 19, 20 in that range? I don't have a fault. It's just raising the load. The fuse is going to melt. And it's real simple and easy to see once you take the fuse out of the barrel. The connection between inside under the paper where it's made looks like somebody just soldered it, right, Robbie? Unsoldered it. Yeah.
That's exactly right.
Yeah. All the fuse pieces are there. Everything is there. It just looks like a piece of melted metal. Faults, though, on it right here, a fault that happens on a fuse is just pretty much going to blow and destroy the fuse. You might find a little bit of the wire braid that goes through the barrel. The paper's going to be burned up. You're definitely going to know the difference between a melted and a blown fuse. Where do we use them? Tap lines, transformers, and capacitor banks. You do not see fuses on feeders. A fuse, once you put a fuse in line with a feeder line, it's not a feeder line anymore.
That's right.
That's not to say, and you may see these, well, I'm sure you will one day. You may run into this pretty quickly. If I have a switch out there that I want to make a line A feeder, I can do it. Here's what I'm using. It's called a dead blade. So a dead blade, what I've done here is I've taken the fuse barrel out of the switch and I've inserted a solid copper blade into it. Obviously, I have no protection here anymore. Riser comes down, whatever size it is, goes through the barrel and into the bottom and then back out. So I've actually taken all protection away from this switch or the fuse and just reinserted a solid metal bar. Now, it is again called a dead blade. All right. So you're going to need to know out there in the world when you start working for utilities, it's a good thing to know and understand, and will actually help you on your troubleshooting later on. And the terminology that happens out there in utilities is some utilities have different schemes for utility fuses. I'll give a couple examples here. Let me get a drink for a second. Diet Dr. Pepper. A Santee Cooper scheme, which they use a fuse saving scheme. And I'll give another example of another company that uses a fuse blowing scheme. There are some benefits to both of them, and there are some shortcomings to both of them. It just depends on what the utility wants to use. Now, do understand also that the fuses, what are they working on? Tap lines, transformers, and capacitor banks. You will see very few utilities that use multiple schemes in their system, because then they have to recoordinate all their breakers to fit it. It's kind of hairy-carry. So what's fuse saving? Well, the first breaker operation is instantaneous. If I have a fault beyond a fuse, no matter if it's a capacitor bank, a tap line, or a transformer, the breaker is going to see the fault. Remember, it's coming from the breaker, and it's going to give an instantaneous open close real fast. When that happens, I've saved the fuse one time, and you recognize how fast it is especially when we do cycles. Hopefully, the fault beyond the fuse has one short chance to clear, and I mean short. I told you instantaneous, of the timing of it. If not, otherwise the fuse will blow. So you're going to get one instantaneous operation. I save the fuse one time, open close, and if whatever it was, say it was a bird or a squirrel, the squirrel did fall away fast enough, then everybody's power is still on, including the person beyond the fuse. I've saved it. Okay, so that's a fuse saving scheme. First breaker operation is instantaneous. Fuse blowing scheme. Now this gets a little bit more difficult. All right, let me jump back to fuse saving. What are the benefits? Who did I have to call out to fix anything, Robbie?
On a fuse saving?
Fuse saving. Yeah, I had a fault. It cleared itself. It just operated.
It just showed up as an operation, no outage.
Yeah, it just shows up in an operation, no outage. I didn't get called at, well, are squirrels up at 3 a.m.?
I'm afraid so.
Okay.
Some are.
So whatever happened out there, they're going to record the operation, but I don't have to get called out for anything. Uh, that's one of the benefit. Reliability is better, and
Right.
you've saved a lot of savings as far as paying somebody to go out and fix these things. The shortfall of it is, well, if I had a operation beyond the fuse, everybody on the feeder saw a blink.
So, yeah.
Yep, everybody on the feeder saw a quick on-off on that entire circuit. You start
Yeah.
getting into cities like Raleigh and Columbia and Charleston, you could have feeder circuits loaded up with 1,500, 2,000 people.
Yeah.
Yeah. A squirrel gets up on one transformer that feeds one customer in a fuse saving scheme is going to blink all 2,000. All right, so that's the shortfall of that in that process. On the other hand, we have the fuse blowing scheme. So the first breaker operation may have a modified instantaneous. Well, what do I mean by modified instantaneous? They still consider it instantaneous. I start fiddling with the times. And what I mean by fiddling is, what I wanted to happen in 1/30th to 1/15th of the second, now I want to happen in 1/2 to, almost maybe 1 full second. That's their first one. It's still considered instantaneous. I'm not waiting for a period of time like 3 seconds or 5 seconds. So I've modified in the breaker my instantaneous. So let's give the scenario here. The squirrel gets on the tap line or gets on the transformer downstream, and what's going to happen is the squirrel is going to get on it, the fault's going to occur, the fuse is going to blow right away. When I say right away, real fast. It just takes more than it can withstand, and the breaker is sitting there, well, I'm waiting for you to clear that fault because I've modified my instantaneous for that fuse to blow.
Mm-hmm.
Now, do take in consideration here, and Robbie, I'm sure you've closed plenty of fuses out there that are blown on you, right?
Yep.
By the time you cut the barrel up and contacted the top of the switch, how fast is that?
It's too fast to even know. I mean, it's just that fast.
You can't even measure it
Right.
by a stopwatch or anything you got in hand. When you start talking cycles and
Yeah.
half of seconds before things happen, guys, you can't tell on your system when you close a fuse and close it on a fault whether you've got fuse saving or fuse blowing. So we are working with some really tight numbers here. I want to let you know that. Okay, so I've modified my instantaneous for a longer time to stay closed, and the fuse is just going to do its job. I'm going to isolate it and open due to a fault current, or there is no instantaneous at all programmed. Now, some breakers and some feeders in stations do this. The first one they put in there is timed. So it's going to be like a 1/1000, 2/1000, whatever their programs at 3/1000, the fault is just going out there until finally I've reached my time limit and I'm going to open. That'll definitely open a fuse. All right. This, and when Robbie and I were talking about it in Myrtle Beach, the majority, I'd say about 80% of the 34 kV is underground. So all of the 34 breakers in Myrtle Beach are set for timed first. Why is that? We know all of our underground is fused, and underground faults are permanent. Now, what do I mean by that? Well, if you dig into it, it ain't fixing itself. Nothing's falling away. Or the cable fails, it's not going to repair itself. So we know those are permanent. So we want the fuse to blow, as quick as possible. We're going to wait for just a moment. We're going to go timed wait. That way, everybody on that 34 kV feeder is going to lose the fuse. I mean, the fuse is going to be lost, but everybody on that 34 feeder is not going to see anything. It might go a little bit dim and come back bright in that situation, but that's about it. So what's the benefits here? That's pretty much what I told you. All right. Whenever I have a fault beyond a fuse, downstream from a fuse, my feeder integrity still stays at 100%.
Yeah.
Yep. Nobody sees it. Nobody knows that fault occurred down there. I don't have a blink. Just simply nothing's happening. What's the short side to it, you're going to be blowing fuses like candy.
Right.
you know, so especially when you get downtown Surfside, downtown Myrtle Beach, man, this place, I don't know. I mean, you need to go start shooting squirrels or something.
Yeah.
I've got a dozen in my yard right now. So on the fuse blowing scheme, you understand the differences between these two. Okay. There are plenty of videos out there of, and I could post a ton of them, but I just want to give this one safety feature here, and I've seen it happen before, and I'm going to talk about it when I talk about the fuse in just a moment and go through some of the pictures. This accounts for the 2-count sectionalizer. Pretty much anything that you close with a stick up there on a pole as far as a fuse is concerned, or the 2-count, do not stand or be under the switch when a fuse is being closed. I'll show you why. Get my fuse right here. Okay, you'll notice in this fuse right here, it's a smaller type fuse that goes into a switch. And when this is the part that's at the top part of the fuse barrel in the switch. So let's go back and forth. So the cap is up here, and the fuse ties in down at the bottom. Now during a fault, if you close a switch, and it doesn't matter what kind of equipment's on, tap line, transformer, capacitor bank, all of the gases, all of the metal, and especially this part right here, it's a spring. It's spring loaded in there to help hold tension. And once that spring is released, open the switch, will be ejected from the bottom of the barrel and start heading straight down. Of course, the closer you are to this situation, the worse. The spring, though, will travel down at a nice, 3,000 degrees centigrade, because that's what it's been faulted to, and embed itself into your body, arms, legs, feet, pants, whatever. So you get the gist here. Do not stand under something. I don't care if it's brand new. You get a brand new transformer you hung up there and you're closing a switch fuse, a fuse barrel on a switch. Get out from underneath that thing. The worst scenario, of course, you could be is, let me get my switch back up here, is that if you're sitting here and you've been working on the pole and you're down here connecting secondary, and you finished up, and the guy in the bucket truck says, I'm ready to go ahead and close this fuse, and you're on the pole with him.
Mm-hmm.
Yeah. Hey, tell him, hey, wait a minute, man. Let me get down. Let me get out of the way before you close that fuse barrel.
Yes.
Okay. So let me bounce back here. Go through these pictures again. Make sure I've got all explanations here. Explanations going on. All right. We talked about the 2-count sectionalizer. We talked about the fuse. We'll talk about this. The types here in just a moment. Good picture of a switch. It's just, you guys know all this stuff. Fuse barrel, insulator, top of switch, high side riser, low side riser. That was just that. Sectionalizer. All right, the dead blade we talked about. Okay, we're going to go into this in just a moment. All right, and this. All right. I did want to talk to you a little bit about these fuses. A long fuse barrel right here, it's got a removable button here on the top. You can remove this button, and on a long fuse barrel, it's actually got a tube that you can shove down there and tie this to. If you notice on this one, that's a short one.
Mm-hmm.
That wire rope will reach all the way. On a long fuse barrel, the fuse barrel itself, the cap part, has an extension on it that you can tie this to. Okay, right inside the cap right here, you'll see the actual ampere size. So you can see it on the box when you get it, or stamped in the top, there's going to be a number, 65. And it tells you it's a 65 amp fuse. All right, the identification, the fuse link type, we'll talk about data manufacturer and the ampere size, the ferrule, fuse link type, color code, which we'll talk about in just a moment, and the spring. On all fuse links through 25A to aid in clearance of the low-level faults by ejecting the fuse. So this, pretty much, you know the deal on this. That is the brutal part in case you have a fuse failure. They will go flying. Okay. Now, I don't want to get too technical on this and go beyond really what you really need to know. But there's a lot of science that goes into fuse coordination as far as your breaker and reclosures are concerned. So if you look here, I got a reclosure in a red line, a fuse on the green line. This is what they call a median. Don't worry about that for now. But this curve here is actually giving you the operating times in, look at the power of the roots, 10 to the negative 2. I mean, this is fast. So essentially what this means is the fuse is seeing the fault for a certain amount of time until this point the recloser sees the fault. And if, depending how you got your recloser programmed to open or close, whatever, the fuse just continues on as the fault remains. Now, if the red line was below, this is fuse. Robbie, can you tell? Is this fuse saving or fuse blowing?
That's fuse. Is that fuse saving?
It is.
Yes.
It is. Because you're coming for a short amount of time,
Right,
real short amount of time, and the reclosure opens.
Right.
Okay. If you came down here and you went a long amount of time, and this was to come up in this area right here, well, the reclosure staying closed, and finally at one point, the fuse is just going to blow, and the green line's going to go out here. So there's a lot of science in it. And again, we've talked about dead blade, no fuse, no protection until next upstream device. Okay. One final thing here, and I'll add it into this document. I'm kind of glad I thought about it right here at the end. Okay, so we know and understand what we need. We're working on overhead lines. Hotline work permit. HLWP, which equals an instantaneous open if we have a fault. Okay, that's a safety feature. And we want it all the time we work on a overhead feeder in proximity to it. All right, most organizations here, if not all, that I've spoken with, and this is the same as the Santee Cooper policy going on here, if I get ready to close switch, let's say close fuse, on switch, you must cancel the HLWP. It's okay, baby. You must cancel the hotline work permit. Well, I don't understand. You've got your hotline work permit. You've completed all your work. Everybody's in the clear, and remember, you can't close a fuse by hand. You got to close it by stick. So you're okay as far as working around the conductors and working around lines to cancel your hotline work permit, because now you're just getting ready to close the switch. The reason why you want to cancel your hotline work permit is if fault occurs. If the fault occurs, you know breaker open. Okay? The breaker is going to do its normal thing, especially in a fuse saving mode. It's going to have an instantaneous operation. That fuse is going to blow, and everybody on the feeder is going to remain on. This happens in all. I don't care if you've repaired something and closed the fuse, or if you've got something brand new and you need to close a fuse, you must cancel the hotline work permit. Otherwise, you're going to take the breaker right out. It's going to come out immediately if you have a fault, and the fuse blows. Now, obviously, if you've got it in automatic, if you've got the breaker in normal, if the fault occurs, the breaker's not going to open, but the fuse is still going to blow. So make sure you give yourself plenty of clearance when closing in with a switch. Robert, I mean, we came up with that. I thought about that last minute. Is there anything you want to add there?
Yeah, I'd like to add about closing in fuses on the ground, versus the bucket. Duke's policy, I'm not sure what Santee, Cooper's policy is, but any kind of oil field equipment, transformers, reclosures, those kinds of things. You're not allowed to close them in while you're in the bucket. You've got to do it from the ground. We've had several instances where, like you talked about, installing a new transformer and the guys climbed the pole to change it, and he closed the fuse with a short stick, on the pole, and there's a internal fault and oil shooting out of it, and he's getting burned by oil. So the safe way to do it is close these pieces of equipment from the ground.
Okay, I went ahead and noted that right there on the Word document, so we can share that too. Santee's policy was a minimum, and surprisingly, I mean, back in the day when we got remember the short sticks, the 4-foot stick?
Yeah.
They used to make a 4-foot fiberglass stick that actually fit in the bucket truck that was just a nice, nifty, quick way to get risers off and open and close switches. Well, those got negated right away. And they made it mandatory that anytime you close a switch, you needed to have a 10-foot stick from the bucket or from the ground. Nobody can close in a switch from a pole.
Right.
Climbing. And then Duke from the ground only.
Correct.
And okay, neither company from ground, right? I mean, neither company from the pole.
Yep.
Company close switch from pole. Now, we've run into thousands of experiences right there, haven't you, Robbie?
Oh yeah.
I had a boss man, and this was a 90-foot pole. I had a boss man. We didn't have a bucket that went up that high. That told me to climb up the pole, and he sent me the extension stick on the pole.
Yep.
So I climbed up 50 feet. It was a 40-foot stick, and then he told me to close the switch. Is that legal?
Yeah. What else you gonna do, right?
Well, it was legal back then, but from the way Robbie's saying it right here, you got to have your feet on the dirt.
Yeah.
Okay. So that pretty much covers everything for today. We're going to throw questions in there on the quiz. You guys are looking real good as far as quizzes are concerned. We got a couple out there that have not really had 100% of quiz completion, but things are what they are. I'd say everybody else is doing real well, so I appreciate your work.
Yep.
Robbie, did we need to go through the KTs, KSs?
Those are probably wouldn't hurt to maybe go through K, KS, X's.
Okay. We can do it right off this document. I will let you know, and Robbie, interject here if you did something different from Duke. When you see these fuses, guys, come out in these boxes, they have a different, the variety you can see down here is huge. KT, Type 200, KS, Type SQ, Type QA, Type X, secondary, and what, blah, 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 blah. Santee Cooper had two types of fuses. They used the Kearneys, and they had a K and a KS. And we'll go read the attributes of them right down here. All right. The Kearney type KS fuse links employ dual element construction, which gives the type K, well, they like talking about themselves. All right, here's what it is. Classified as very slow fuse links. So, I told you on the Santee Cooper system, for a little guarantee here, they want a breaker operation first. They want a fuse saving scheme. So this is what they use in all their tap lines and all their transformers. Classified as very slow. I want to take a little time for the breaker to give me an instantaneous operation, fuse links. Then after it's given me that operation, I'm going to blow. So KS, and the tube color type is blue. T's are slow fuse links. X's are dual element. Be careful of the shape of those. Surge. All right, so they avoid nuisance blowing from lightning and switching surges. So they're kind of hugely slow. All right. To give you one example, I don't know if they got the K. And you could probably find, well, they got tons of charts in here. Speed ratios, T's, yeah. So I'll give you one example of this. We use KS's on all of our tap lines and all of our transformers. We want it to wait a moment for the breaker operate. The only place where we used a K, which was considered here it is,
Yep.
considered a fast fuse in this case, was on a capacitor bank. Now, I know we talked before about capacitor banks and how volatile they can be, and there's a couple of reasons here. I want this thing to blow real fast and really just as fast to not even get recognized by the breaker. I'm not going to have a breaker instantaneous operation at all. Two is if it blows fast, it clears the capacitor bank from any further damage. Three, I don't care if it blows fast because I have lost no customers.
Mm-hmm.
Does that make sense?
Yeah.
Yes. The capacitor bank, it can be out. I can come out and repair it later on, but there's no customers being out. So you'll probably see you won't probably see, you will see. What's the difference between a K, KS, and what one did you use, Robbie?
X.
X-type fuse, which, let me read through this fully. Transformer protection.
Yeah,
Well,
transform.
Be carefully shaped to closely match. Loading for transformers. Excellent surge withstand to avoid nuisance blowing from lightning and switching surges. The nominal speed ratio of the fuse lengths is 32. So I would consider this to be an extremely slow type of fuse in this situation. If it can withstand a lightning surge and switching surges, and you still want to have that fuse be viable, then that would be extremely slow.
Yeah.
Okay. Robbie, you think that wraps it up?
I think so. You hit the high points.
Okay. You're going to get this in one video. I'm going to include another video and I'll show you the picture right here of what you can use on this switch if you need to open it while it has load on it. Okay. Remember, this will go up to 125 amps. I've seen cases where it's hard to break load with 5 amps. When you open the switch, you're going to start drawing an arc. There's actually a tool that's out there that's made to hook onto this top horn of the switch in the fuse barrel called a load buster. You're going to get a video on that and questions on that also. Okay, I think that wraps it up. Robbie, any other thing you would like to add?
Nope, I think we covered it all right there.
Okay, man. Well, I appreciate you guys' hard work.
Yep.
And let me see if I can get to this. Here we are. Gentlemen, have a good day.
See you guys.